The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. How you guys doing? We'll be doing our half-hour free training session starting now. With me, as always, is Kevin Rankel. Hey, Kevin, how you doing?
Hey, everyone. Doing good.
So kind of a continuation from yesterday. We were doing tool tables and tool definitions yesterday. Today we'll do kind of the next step up. What if you had a tool that didn't match any of those default shapes? If it's not a flat end mill, not a ball mill, not a barrel mill, what if it's a contoured shape? Like Kevin was mentioning yesterday, a corner round tool. That is also not a shape in our list. So how do you do shape tools? Well, pretty much the same thing. You go to Tools, SolidCAM, Tool Library, and then you can go to Shape Tools. You can see we already have a couple of shapes here, and I have this one here as well. So basically what you'll do to add a shape to your shape tool is either add it to one of the groups. So let's say if I were to add it to one of my chamfer tools, or I can add a brand new group here. Let's just call this one SolidCAM Live. So the group basically just groups the tools here. I can right click again and say add. And now it brings me to this screen where I can actually define the shape of my tool. So you'll see on the top here, top right here, we've got all these building blocks here to build the shape of your tool. So you start from the tip and you go upwards. So let's say we were going to build that corner round tool. I would choose this, I guess, this concave shape, or a torus, I guess it's called. So you can get the bottom tip of your tool. There's your corner round right there. Obviously, that's not going to end at that kind of infinity point there. So we need to add a little bit of a cylinder. And then we can add another cylinder to represent the shank. And then once you have these tabs show you the dimensions of each of those individual shapes. So let's say, for instance, let's go with the radius here. Let's put a radius of just maybe 250. As soon as I do that, you can see it starts to take shape. That thing was, it's kind of it's called a torus. So the tip has a diameter and the top has a diameter as well. So you have the top diameter here, you have the bottom diameter down here, and you've got all these different things here to kind of shape it. So if we take a look at them going down the list here. So I already did the radius just to kind of get this thing to size. We know we want to make this a corner round tool. This shape right here, let's say that we want that to be maybe 1 inch. So I'd put 1 inch in there, and again, it begins to take shape. The sweep of that radius, of that arc, we'll say it goes from 0 to 90, so that's already defaulted for us there. But if this was any other shape, remember, this is a building block, you can set that sweep to whatever you like. The bottom tip, well, I'll let that auto-calculate for me based off the fact that I gave it a top diameter, a radius, and a sweep. I'll let that figure it out for me. And then the max diameter basically is just the max diameter of the entire part. So we got that 1 inch there. Now, building the rest of this tool, we go to cylinder 1. If the top diameter of this building block is 1 inch, this guy should be 1 inch as well, or else it doesn't really look like it makes sense. We'll just say 1 inch. Okay, and the height of that cylinder. It's a cylinder. There really is only 2 dimensions, so just diameter and height. Let's give this guy maybe just a 1/4 inch of height. So we get that little guy there. It kind of looks a little more familiar to us now. And then cylinder 2, if that represents the shank, well, let's give this a proper diameter for the shank. Quarter round tool, Kevin, what would you say for the shank?
Yeah, we can just go the same size, the 1 inch.
Right. So in that case, we didn't necessarily have to add a second cylinder, but it gives us the ability to define the different diameters there. So again, very representative of what you would do with this sort of tool. And then the height, that could just be the remainder of the overall height. And let's just set that to 2 just for simplicity. So there you go. So this is the edit page. You have all these options here to add stuff. And if you go to the show page, you can see what your tool looks like.
And you guys can take and drag that dialog to make this much bigger so you can fill up your entire screen, so you're not, for some of us old guys that have to squint.
Some of us old guys. How old are you, Kevin? I'm older than you, man. But he's right. You can always bring this up and you can take a look at it, especially if you have that fine detail. Because again, you can really zoom in. You can see our little faceting there. You can really take a look at this thing. And let's actually change this one to maybe just a 1/2 inch, so we can just see the differences in the cylinders. What am I doing wrong here? That is diameter. There it is. Okay. So now you can see the differences there. Okay. So this is the shape definition of your tool. This isn't actually the tool yet, because you can actually apply this in many different ways. So let's just take this. We'll do a save and exit. And let's go and actually create a tool table now. So similar to what we saw yesterday, we'll go to create tool library. I'll make it a mill turn just for sake of practice. And let's call this SC Live once again. You add your tool. You still choose one of your default shapes here. And what you'll do is you'll actually apply the shape to one of these defaults. Now, the recommendation from, and I guess maybe Kevin would agree with me, is to use the flat end mill.
Yep.
Because it's very simple. You just basically are just giving it a diameter, maybe an overall length, outside the holder length, really, if you're adding a holder, and then number of flutes and all that. But really, the only thing that's going to apply for the shape is the diameter and possibly the cutting length. We're going to take a look at that as well. So what you get when you do the default shape is something like this. It recognizes the shank, it recognizes the cutting length, denoted by the cutting length here, and the diameter. That's how you would define a very standard shape from that list. Now, if we're going to apply a shape tool, go to the Shape tab, and we look through our global list until we get to the group that we're looking for. There's our shape there. If I click on it, I can see the shape. I can double check to make sure that that's correct. It's when I check the box that it actually applies the shape to our tool. So this is still defined as a flat end mill, meaning I can use this in tool paths that receive a flat end mill definition of a tool. But when we get to the topology page, you'll actually see that the length is pretty much the entire length of the entire definition of the tool. So we need to correct this. For one, we know that the diameter of this thing is 1 inch. So I'm going to make this 1 inch. You can go through and make this a little more accurate. Let's say, for instance, we know the arbor is 250. This right here, I don't think it really affects much, but you know, if you want to put in the values, you can. But really make sure that this one represents the outermost diameter of your tool, because that way you can actually, when you do your tool paths, you can use that diameter for your offsets. And we can talk about that a little bit once I finish these definitions here. So you can see the overall length is grayed out because it's read from that shape. Outside the holder, you can control that as well when you add your holders. You can see that it'll actually move that dot, and it's not letting me do that because this is still 250. So let's make that maybe 1 inch. And cutting length cannot be that much. Let's just do, I think that was about, it should be that much right there. So as soon as I change the cutting length, you'll see the color of my shape tool change. That's because these two colors represent the same thing they did for the standard tool shapes. This is a non-cutting surface. This is the shank. And then this is the cutting surface of the tool. Now, in reality, this one's probably more like something like this, I think. Possibly. But this is just an idea here of that is a cutting surface and that is a non-cutting surface. So when you use your shape tools, define it as a general shape from the standard list, and then come here and modify these dimensions so that you can actually use it. Now, the reason why I say you probably want to put in an accurate diameter is because, again, you're going to use this for your offsets. And what actually happens with this, let me just bring this back on screen so it kind of lines it up better, is it takes that diameter to the tip of the tool. So there's actually an imaginary point right about here that represents the outermost diameter of the tool and the tip of the tool. This is the point that actually rides along your tool path, because remember, this is still defined as a flat end mill, so it's looking for that bottom tip. So when you do any kind of profile tool path or anything like that using this tool, you're going to tell it to just shift a little bit upwards and maybe even inwards so that the imaginary point is in here and you actually form that shape there. Okay, so that is a very easy way to do your shape tool. And again, if your shape tool is more like any one of these other ones, then go ahead, choose one of those. And then it actually gives you the ability to define it a little further. Let's say you had a specialized tool that was a flat bottom, a little bit of a radius. The rest of it might be a completely different shape. But if you wanted to define that radius for whatever purpose, then you define it as a bull end mill, and then you bring in your shape, and then you just put in the same default kind of dimensions here.
And how to tell, stay in there, Mark, for a second.
Yep.
A good way to tell if Mark is using a shape tool, just by if he has 500 tools in here, is there is a little icon right by the number 1, and that's identifying that that is a shape tool for you guys. So if you're trying to search through and look for a specific shape tool, you can. That's one way to kind of look for it.
That's a really good point, because you will have many thousands of tools, and because you're defining your shape tools as by default just a flat end mill, the icon other than this little symbol here is not going to give you any indication that it's a shape tool. Other than that, maybe you give it a name or something like that, but oftentimes we don't have this thing this wide open where you can actually see the names. So that is one way to do a shape tool, just simply using those building blocks, and that's it. But let's say you had a more convoluted tool. You can actually use, if we just get out of here, and we'll just go back to that shape tool library again. Instead of these building blocks, you have these options down here. You can actually import a sketch from SolidWorks. So again, instead of using all those building blocks and getting all the little radii and all the little steps in your specialized tool, you can actually bring in. I'm not sure why it's doing that. You can bring in a sketch from SolidWorks, and you can actually use that rotational profile, assign the chain. So you can see here it says define chain. You can choose that chain. You can choose your reference point. Usually I recommend the bottom center of the tool. And then when you actually select the chain, what it'll do is it'll convert it into these building blocks for you. So you'll see many different tabs here representing each building block. But each building block is each radius, each cylinder, each torus, cone. It just builds it for you out of those building blocks. So you don't actually have to go and step-by-step build these. So if you have a very, sorry, Kevin, go ahead.
This works really good if your tooling vendor has sent you a solid model of your tool itself. So what you can do is just open up that solid model and go into the sketch, and then you can actually copy that sketch over and bring it into, so when Mark clicks on import, he can hit paste and bring that sketch in there, and then you can just use that as your sketch geometry, or you can actually insert that tool right into that import sketch button as well. And like I said, SolidCAM is just looking for that revolve and then just chain half of that tool.
100%, and that's actually the procedure that's listed in our shape tool video on YouTube, on the YouTube channel, either yours or mine. I forget which one we show it, but that's exactly the procedure we take. Because oftentimes, like Kevin said, your supplier will supply you with a step file or an IGES file, or even sometimes even an STL file, and you'll just take that cross-sectional sketch, paste it into the same window, so you don't actually have to build the sketch yourself. It's an additional step, but you're getting that complex shape. And what I'd like to do is I want to bring up a library that uses that complex shape to build a tool. Now this one is for one, let me see, let's go to tool library, edit tool library. This was for a customer actually up here in Canada that does architectural wood railing, like really fancy wood railing for the kind of house that I would never buy. And he wanted to do with a 5-axis toolpath, just one sweep of a toolpath, and he had a shape tool. Let's go here. Yeah, so there it is. And then it was under, you're seeing the internal workings of Mark's computer. We're going to go over here, this one here, and I think it's that one.
I think this was off of Rick McAllister's house.
What, is Jake not in today? Is that why you're picking on Rick? Look out, everybody. He's going to pick somebody every day. All right, so what we have here is kind of like what Kevin was saying. So I have a bunch of these shape tools. They're all defined as flat end mills, but they have that little icon next to it indicating that these are actually defined as shapes. Now, not every one of these was actually a pure shape. It looks like this customer, he built this thing. I guess he wanted to have the holder represented there for whatever reason. Another one here, and then, if I'm right, our shape tool. So this one was built from a, basically like Kevin described. It was a solid tool. I think it was an FTP file that was sent to the customer, and he created the cross-section inside SolidWorks, imported it into the shape tool window that we were just looking at, and it built the shape for us. So it built the cylinder. This is a spline, kind of a complex curve. So each one of those is a different torus with a different top and bottom diameter with a different radius. And this was his shape tool. This actually formed the bottom of the radius of the railing. So this was the nice little curvature of the railing. Actually, I think it was the other way around. Once this part was done, this was actually the top of the part over here. So it has that nice curvature and then he would do the other side with the same 5-axis toolpath. And you can imagine what a railing looks like. That was basically the cross-section of the railing. And then he used this in 5-axis. And the way we defined it in the 5-axis toolpath is instead of the bottom corner being right there, he actually defined it to this point right here. Because in 5-axis, as you probably have seen, it's surface-based. So that bottom edge of that surface was the contour he chose in his parallel to curve 5-axis toolpath, and he told the tool to follow this point right here along that curve, and it formed that shape as it went in 5-axis. So really complex stuff you can build simply by just letting the geometry do the work for you.
And we actually, at my old work, we had to do this quite often because we did a bunch of custom porting tools for breathing machines and for a medical company, and it would take me a year to draw up all the different shapes and forms that are in there. So that's the nice thing about importing that right in there.
I think I actually have a representation of that as well. So let's go take a look at that as well here. Let's go edit tool library. So at this point, I think we're about halfway through. Any questions on this? Anything from yesterday? Anything in today's session we can cover for you guys?
Let's go ahead and show that toolpath. Let's do just a square part with that radius on there, and let's apply that shape tool and see what it looks like in Solid Verify.
Oh, I was jumping ahead. I was just going to show you the. I think it was this one. Yeah, never mind. I was going to try and find that porting tool, but if you're interested in what Ken was talking about in terms of what the porting tool looks like and how we can use it, there is a port machining toolpath or a specialty tool machining toolpath on our YouTube channel. But you want to see how we use that shape tool?
Yeah, let's apply it to the part.
I can probably pull up the part.
And it doesn't have to be the railing one if we just did like a corner round.
Oh, the corner round tool. Yeah, we could do that. Okay, let's just load a. Let's go over here. Okay, so our old friend here, the sensor housing. You've seen this in a lot of the YouTube channel videos. Let's add a corner round all the way around there. So I'll just add this to the top. So we'll go profile. And the profile, I'll just do the top edge of the entire part. I'll grab my edge there, constant Z all the way around. Tool, select. Now, since I didn't get a chance to actually define that tool and save it anywhere, we'll do it here. So I grab a flat end mill. We'll go to shape. There's our SolidCAM Live. I'll add the shape. And like we did before, let's actually define this thing. So this is 1 inch. It has a cutting length of 1/2 inch. Let's just double check that that's coming in correctly. There it is. Okay, so selecting that tool. Levels, let's just say we'll go from there down that 1/4 inch. Technology left side, and just for the sake of demonstration, we'll just add this right here real quick. Okay, so I have a toolpath, and you can see that I dropped it by a 1/4 inch. But remember I said that you need to kind of shift it over, because if we take a look at this in HostCAD, let me get that shape on screen. So the bottom corner right here, that's the imaginary corner that's going to follow my chain. If we kind of step through this code, you can see that it's not coming in on the right angle here. All right, let's get this view like so. So it still thinks that the 1 inch diameter is what is the offset. So I dropped it by that 1/4 inch. I have to bring it in.
So to accommodate that, what Mark can do is he can actually, instead of saying that his tool is a 1 inch cutter, what he can do is tell that tool it is a 1/2 inch, because that's based off of the smallest diameter of that shape. So if you go define your tool, because that tip diameter would have been 1/2 inch, if he puts that at 1/2 inch, it will calculate all perfect.
It's a matter of the shift, right? So if we take a look at this now, let's go and step through there. So what Kevin has done is, if he says that this is actually the diameter to ride off of, then that is still the bottom corner of the tool. So this is one way to do this, but for overall, for a shape tool, you're not always going to have a nice tip like that you can follow. You might have a unique shape, kind of like the railing example, because the shape of the tool is not always going to fit exactly the chain that you want to follow. So you want to basically just have an idea of the shape of your tool and how you want to shift it. So if we go back, let's say we had a tool like I defined it without the actual nice shape of being able to say that this is a 1/2 inch on the bottom. Let's say I know I have to shift it by a certain amount. I can still grab the same chain from the geometry, but what I want to do is I want to use the geometry section to actually add a negative offset. So in my case, I'm actually going to do a -250. Take a look at that. What that'll do is that brings it inwards a little bit. You can see that yellow line now represents the new chain. So we'll get that side view once again. So it's very close to doing the same thing that we did with Kevin's part, except that I don't have to change the shape of the tool. I can define it as being there in case I need to do some sort of offset based off of the maximum diameter. If you know your shape tool, you know how much to shift it by, especially if it's an irregular shape tool. And like you saw with the Canadian railings one, it has some odd shape to it. There's nothing on there that actually should be touching the part other than that one arc, that one shape to it. So it's just a matter of when you bring it into your profile or your pocketing or your 5-axis, know the shape of your tool and you know how much to shift it in the axial and the radial direction. If we take a look at that in Solid Verify, we'll actually see that it makes the corner round shape like that.
Until you forget to remove the rest of the stock in there.
Yeah, until you break it, and then there's that form tool that you paid so much money for and it's broken. Any questions on that?
Nothing coming in yet.
Okay, let's close this guy out.
We can officially start now because Jake showed up now.
A note on shapes in general, that same building block can be used to make your tool holders as well. So very similar to what Kevin talked about earlier this week. If I want to add a shape to one of these default shapes, if I want to make my own new group here, let's say we make a new group called SolidCAM Live. And then if I add to that, I'm actually adding a holder to that as well. So starting from the tip, do one of those, do one of these, not that one. Is there a way to delete that? Guess not. Let's delete this one. We'll add a new one. And I'll do this, and this one again. So I get that kind of top shape there, and then one of these. And what you do is you get your holder. So it's the same building blocks used for your shape holders as the shape tools. If you have a STL file for, let's say, a holder for your mill turn, that is a whole different thing. And there are YouTube videos on our YouTube channel covering the use of STLs for holders as well.
But pretty much covers it all. One thing to remember is, even though that Mark made all these dimensions in there, let's say you, I think we kind of talked about this, I think it was yesterday or the day before with the holders, but if Mark is in the local library and he wants to make a change to that shape, you guys don't have to go out to that, the tools, shape tools, and make the edit from there. You can actually edit that shape right inside of your tool library.
Yep, so shape.
So as soon as you hit that checkbox, it will enable the edit. And now he can go on there and click the edit tab, and you can modify the numbers right in there as well. Just remember though, when you make the changes in here, it's only going to stay to this library only. It will not go back and change the original shape holder that you originally drew up.
So let's see if there's any questions. So Jake was late because of his internet. Okay, well, this is when we introduced SolidCAM Internet. No.
So where are the global shapes and tool holders in the file system? Great question, Brian. You want to show that?
Where the holders are saved in the system. Oh yeah, okay. That is. Let's just open up a folder.
Now this will depend if you guys are running Intermetric.
So that is, the default location is your C drive, users, public documents, SolidCAM, whichever version of the software you're using. So let's go 2020. And then that is under tables. And like Kevin said, inch or metric. So let's say we go to the inch. And then here is your THT file holding your holders. So that's just kind of a group of all the holders. Here's your TAB files that we've been creating throughout the week. If you made any kind of STL holders, those are held in here somewhere as well. I think maybe even that same folder.
There's an actual folder for it.
There's a folder there. Yeah, there it is. Okay.
So that's where all your stuff is being stored. It's all basically internal using these THT files in here. So.
Yeah, and to see if you are actually pointing to that proper folder, that's under SolidCAM settings, and that's that first section in your SolidCAM settings once it pops up here. User directories, and it's being held in the, I guess it's the additional files, right?
Yep.
Yeah, so there it is. Perfect.
And that's the one we were talking about yesterday when we were going over the tool libraries, that one can be stored out on the network as well as your tool tables.
Absolutely. You can make all of these network locations. Pretty much any address you see for a folder in these settings can be made into a network location. The only one you don't want to do, I think, is a temporary folder.
Yep, correct.
Right? Yeah, temporary folder you want to keep local always because that's really just for you. Okay, yeah. If there are any other questions, of course, there's still tomorrow and there's still next week. So you can send them to my email that I'm going to put in here in the chat area. If I can remember how to spell my own name. There it is. And this is the 30-minute free training that we're doing during this period. If you are interested in one-on-one training, give me a call, email me, or contact your local salesperson, and we can get into a training session one-on-one. Actually, over the phone, we can communicate. You can ask your questions live. If you know anybody else that would like SolidCAM, I don't know if we send out emails on this anymore, but there is actually a finder's fee. You can get a little bit of something for getting some of your friends interested in SolidCAM, and even if they purchase. So if you're interested in that, also contact your local salesperson and get some details on that, because that's actually a nice little, community kind of based way of selling that we really enjoy doing. A lot of our customers, it's word of mouth, and that's usually the best way because we can show you stuff in a demo and all these flashy videos and stuff. But if you actually are the one that feels confident in the software and you let your friends know, then they know for sure that that is a trusted software.
And that actually just happened to one of our customers over in South Dakota. He took him and his family to Hawaii for a week, all from his telling SolidCAM to his buddy. So it definitely pays.
Yeah, he probably has one of those houses that has that railing we were talking about.
Yeah.
Okay, so last question, I guess that's there from Jake is, when will this be posted? Kevin, you're the one that posted it. How long does it take?
So it'll be about 40 minutes to render out the video.
Perfect. Okay. So like I said, we're doing this every day. 2 p.m. Eastern time. And if you have any trouble getting in, you can always try emailing us. We can always resend you the link in case there's some sort of registry issue. But we will talk to you guys tomorrow at 2. Stay safe. Hope your families are safe, and have a good day.
All right. See you guys.